So today we're going to look at rational expressions or rational functions. All right, so let's look at a few exercises. We'll go through them together. So the first one is, which of the following are rational expressions or functions? Let's just write that in, or functions. So remember what a rational function is. Rational function is a fraction of polynomials. So first thing we're going to do is go through each exercise and determine if we have a fraction and if it's a fraction of polynomials. So in part A, everything's a fraction because we can put it over 1. So in the numerator, we have the square root of x squared plus 4. So x squared plus 4 is a polynomial, but the square root is not. So this is not a polynomial fraction, so this is not a rational expression. So part B, 3x squared minus 1 over 2 minus x. So this is a fraction, and the numerator and denominator are both polynomials, so yes, B is a rational expression or function. Part C, all right, so we have a fraction. We have sine of x squared over cos x plus 2. That's good, we have a fraction. However, the trigonometric functions are not polynomials, and sine x squared and cos x are both trigonometric functions, so no. So far A and C are not rational expressions or functions, and B is. So part D, so we have a fraction. So in the numerator we have cos squared x, and in the denominator we have the square root of x plus 1. So neither the numerator or denominator are polynomials. Again, in the numerator we have a trigonometric function. In the denominator we have the square root function. So no, this is not a rational expression. Okay, so let's go on to number 2. Okay, so number 2, for those that are not rational expressions, in number 1, explain why. So I think we went through that when we were going through number 1. And we don't have a 1 there. So as mentioned when we're going through all the exercises in number 1, in order to have a rational expression, first we use a fraction, and that fraction is a fraction of polynomials. So the numerator is a polynomial and the denominator is a polynomial. So functions like the square root or trigonometric functions, exponential functions, and you'll see different types of functions later. I think in your advanced functions course, those are not polynomials. So as a result, they are not, A, C, and D are not rational expressions. All right, so let's go on to number 3. So what does it say? Simplify the following and state restrictions. Okay, so let's give this a try. So the first one is, why don't we do that over to the left-hand side? So 3x minus 6 over 2x squared plus x minus 10. All right, so they want us to simplify, so let's rewrite it here. So 3x minus 6 over 2x squared plus 10, oops, let's get our eraser out, plus x minus 10. So we want to simplify, so that means we're going to factor our polynomials in the numerator and denominator and see if we can find some common factors. So in the numerator, we can factor out a 3. That's pretty easy. 3 times x minus 2. And down the denominator, we have a 2-degree polynomial or a quadratic. Let's see if we can factor that. All right, so it usually means we're going to have 2 factors. Let's see, probably 2x and x. Let's see. Now, what are the factors of 10? They're 5, 1 and 10, and 5 and 2. So let's try 5 and 2. All right, so now we got to get our signs, the positive and negatives, in the correct place. So let's put positive here and a negative there. So if we do that, then if we multiply it out, we're going to get 2x squared minus 4x plus 5x minus 10. So the 5x minus the 4x give us our x. So looks like we've factored. And if you notice, we have a common factor of x minus 2, so we're going to cancel those out. And then we're left with 3 over 2x plus 5. All right, so we've simplified. Now we need to do the state restrictions part. All right, so what does that mean? So when is a fraction not defined? So a fraction is not defined when the denominator, when the denominator equals 0. So let's determine when the denominator equals 0. So in this case, our denominator is 2x squared plus x minus 10. So we need to find all the values of x when this polynomial equals 0. So we did factor, and we factored the denominator to be 2x plus 5 times x minus 2. So in each of these factors, when either of these factors, equals 0, then our denominator equals 0. So we can, why don't we quickly do it down here, or x minus 2. So this is for the restrictions. All right, so 2x plus 5 equals 0. So that occurs when x equals negative 5 over 2, or when x equals 2. So these are our restrictions. All right, so that takes care of part A. All right, so let's change the color. All right, let's look at B. So B is 6 minus 2m over m squared minus 9. Do we have a little space on the right-hand side? Yes, we do. So let's move over to the right-hand side. I don't think we need to rewrite it, so let's not waste time. So now let's factor the numerator. So the common factor of 2. So let's factor that out. We're left with 3 minus m. 2 times 3 minus m in the numerator. Now in the denominator, we have, again, a quadratic second-degree polynomial, and it happens to be a difference of squares. Remember that? So when you factor a difference of squares, again, two factors, and they look very similar. So we have m squared, so our first term is m, our m's in the brackets, and our second term in our quadratic is negative 9. Let's go with 9. And it's a perfect square, so the factors are 3 and 3. We're going to use those. Now we need to put our signs in. All right, so plus and minus. All right, so now we need to see if we have any common factors in the numerator. Well, actually we do. So the numerator, let's factor out a negative 1 from the bracket. Okay, so then we have negative 2 times m minus 3. In the denominator, we have 3 plus m times m minus 3, and we see that our common factor is m minus 3, so let's factor those out, and we're left with negative 2 over m plus 3. All right, so we simplified. Now let's look at our restrictions. So again, our restrictions are when the denominator equals 0. So in this case, when is our denominator equal to 0? So our denominator factors out to m plus 3 times m minus 3. Okay. And when does that equal 0? When m equals negative 3 or positive 3. So these are our restrictions. So they're so we want a concluding statement. Good. All right, so that takes care of the second one. Now let's look at the third one. Okay, so in part C, we have 2y squared plus y minus 10 over y squared plus 3y minus 10. All right, so let's start by factoring the numerator and denominator. So I'm just assuming they can be factored. That could be wrong. All right, and okay, very interesting. So if you notice, the numerator is exactly the same as the denominator in part A. And we did factor that. So we can factor that one again. So remember the factors we got for that? Okay. So the numerator factors out to 2y plus 5 times y minus 2. So now the denominator, let's see if we can factor that. So again, we have two factors. We're going to going to be linear. We're going to have a y term as a first, we're going to have a y term. We're going to start with the y term and then look at the factors for 10, 5, and 2. And then the cross term is positive 3. That probably means we're going to have something like that. So let's check. So y times y is y squared. Y times negative 2 is negative 2y. And then we have 5 times y is positive 5y. And then 5 times negative 2 is negative 10. So the positive 5y and the negative 2y gives us our positive 3y. So it looks good. So now do we have any common factors in the numerator and denominator? Yes, we do. The y minus 2 terms. Let's cancel those out. And we're left with 2y plus 5 in the numerator over y plus 5. Great. And then finally the restrictions. So again, when or how do we find restrictions? That's when the denominator equals 0. So when is the denominator equal to 0? When one of these two factors equals 0. So that means, therefore, when y plus 5 equals 0 or y minus 2 equals 0. This means y equals negative 5 or y equals 2 are the restrictions. Good, and we're done. So we've simplified each rational expression and we've stated the restriction.